By the early 1980s, SLR lenses reached a level of brilliance few believed possible. Coating so advanced that reflectance dropped below 1%, precision so tight that rejection rates fell by more than half. A compact feel that defined the era. The world calls this the golden age for SLR lenses. But why did everything peak at once? And what was lost when autofocus arrived? Light, when it meets glass, doesn't simply pass through. At each air glass boundary, a small but significant portion bounces right back, enough to create flare, washed-out color, and ghostly reflections that plagued early SLR lenses. The solution, perfected by the early 1980s, was multi-coating, a process of layering ultra-thin films onto each lens surface. Each layer, measured in fractions of a micron, is engineered to cancel out specific wavelengths of reflected light. The result is dramatic. Where an uncoated lens surface might reflect 4% of incoming light, a well-executed multi-coating drops that figure to less than 1%. Canon's Super Spectra coating, or SSC, stands as a clear example. Take the Canon FD 50mm f1.4 SSC. In backlit scenes, this lens holds on to contrast and color where its single-coated predecessor would surrender to veiling glare. Photographers in the early 80s could see the difference instantly. Deeper blacks, richer saturation, and a crispness that made images pop, even in challenging light. To the eye, these coatings often reveal themselves as subtle color sheens, magenta, green, or amber, dancing across the glass at an angle. But their real proof lives in the photograph. A side-by-side comparison, same scene, same exposure, shows the multi-coated lens delivering more punch and clarity. This leap in coating science set a new baseline, not just for technical excellence, but for the look and feel of images that defined the golden age. By 1984, the SLR lens market had changed in ways that were impossible to ignore. Multi-coating, once a premium feature, became the new standard. Japanese manufacturers led by Canon, Nikon, Minolta, and Pentax released catalogs filled with glass that shimmered with anti-reflective layers. According to Nikkei Electronics, more than half of all new SLR lenses sold in Japan by the mid-1980s carried multi-coating as a baseline feature, a milestone that signaled a clear break from the past. The shift wasn't just about numbers. Designers were suddenly free to experiment, adding more elements to each lens without fear of runaway flare or muddy contrast. This freedom led to bolder optical formulas, faster apertures, more ambitious zooms, and wide angles that could tame distortion while still delivering punchy color and crisp detail. The classic 50mm primes grew more consistent, while new super telephotos and complex zooms entered the market, each taking advantage of coatings to control reflections across a growing number of glass surfaces. For consumers, the payoff was immediate. Lenses once notorious for unpredictable performance in backlight now handled difficult scenes with ease. Sales figures followed suit, with multi-coated models quickly eclipsing their single-coated ancestors on store shelves and in export shipments. The commercial triumph of these coatings didn't just transform the look of photographs. It rewrote the rules for what lens makers could attempt, setting the stage for a new era of precision manufacturing and optical ambition. By the early 1980s, lens factories bore little resemblance to their predecessors. Computer numerical control, CNC, machines began to dominate the production floor. Where skilled hands once guided every grinding wheel, now software and precision motors shaped glass to tolerances measured in microns. Nikon's Ojai plant, a leader in this transformation, adopted automated surface generators and computerized metrology systems, reshaping the meaning of quality assurance. Batch rejection rates, which hovered around 7% in the late 1970s, fell to just 2.8% by 1983, according to internal QA logs. This wasn't just an incremental gain. It meant fewer defective elements, less hand sorting, and a dramatic reduction in optical variability from one lens to the next. Statistical process control became the new language of manufacturing. Instead of checking every 10th lens by hand, automated interferometers and MTF benches verified sharpness and centering for most of the production run. Sample-to-sample variance, once a persistent headache for both engineers and photographers, dropped by half or more. This new consistency allowed designers to push boundaries, tighter edge sharpness, more ambitious lens formulas, and the confidence that what left the factory would perform to spec. The Nikon AIS 50mm f1.4 stands as a testament to this era. Reviewers and collectors still praise its evenness from center to edge, a direct result of these factory upgrades. The so-called Nikon OHI metric, a shorthand for this new standard of batch uniformity, became a quiet benchmark within the industry. For photographers, it meant that the lens in their hands would deliver the clarity and contrast promised in the catalog, not just in the lab. This leap in manufacturing precision set the stage for the tactile and optical confidence that defined the golden age of SLR lenses. A lens from the early 1980s doesn't just impress on paper, it leaves an impression in the hand. The moment a photographer picks up a Pentax M50mm f1.7, the difference is immediate. Barrels became smaller, yet every surface feels solid, every turn deliberate. The focusing ring glides with a gentle, even resistance, the result of carefully machined brass helicoids and just the right amount of damping grease. Each movement is silent, confident, and precise. Qualities that reward slow, intentional shooting. Designers of the era chased compactness without compromise. The Pentax M line set a benchmark. All-metal construction, minimal bulk, and a balance that makes even a modest SLR body feel nimble. At 155 grams and just over 3 centimeters long, the 50mm f1.7 can disappear into a jacket pocket. Yet the tactile feedback, those crisp aperture clicks, the smooth focus throw, remain satisfying, never toy-like. This mechanical refinement was no accident. As factories adopted tighter tolerances, engineers focused on the user's experience as much as the optical chart. The result was a generation of lenses that felt as good as they performed, encouraging photographers to trust their hands as much as their eyes. Even today, collectors and shooters praise the helicoid feel and compact solidity of these designs, citing them as reasons to return to manual focus glass. The physical connection between photographer and lens, so carefully engineered in the early 80s, set a standard that even modern autofocus lenses often struggle to match. At the 1985 Consumer Electronics Show, Minolta unveiled the Maxim 7000, the world's first SLR with fully integrated autofocus and motorized film advance. The announcement landed like a thunderclap. Behind the scenes, Minolta's engineers had spent months reworking the lens mount and internal mechanics to make autofocus possible. Gone was the long, fluid focus throw that defined manual lenses, replaced by a shorter, stiffer movement engineered for speed rather than tactile precision. Every millimeter of internal space was contested, as designers carved out room for electronic contacts and motor couplings. Just as the Maxim neared production, legal threats from Honeywell over autofocus patents forced last-minute recalibrations. Minolta's team scrambled to adjust firmware and tweak mechanical tolerances, racing to avoid a sales injunction. The result was a lens system that felt fundamentally different in the hand, optimized for rapid electronic actuation, but sacrificing some of the mechanical grace that had defined the golden age. Industry rivals watched in shock, realizing the rules had changed overnight. Within hours of Minolta's Maxim 7000 reveal, conference rooms across Tokyo filled with anxious executives and engineers. Canon and Nikon, blindsided by the reality of a working autofocus SLR, called emergency meetings, some lasting through the night. Factory managers pored over telexes and internal reports, while R&D teams drafted fresh blueprints on whiteboards, still smudged from last week's plans. The Minolta MD 50mm f1.4, a manual focus masterpiece just a few years old, now stood as both a symbol of refinement and a reminder of how quickly priorities could change. In these urgent sessions, the question was no longer how to perfect the feel of brass helicoids or the weight of aperture rings, but how to deliver speed, autofocus speed, without sacrificing everything that made these lenses beloved. The industry's pursuit of mechanical grace collided head-on with the demand for electronic innovation. What followed was a scramble, not just for market share, but for a new definition of excellence, as the golden age of craft gave way to the race for automation. By the early 1980s, computer-controlled grinding had reduced lens rejection rates from 7% to 2.8%, and multi-layer anti-reflection coatings drop surface reflectance below 1% on models like the Canon FD 50mm f1.4 SSC. These advances, documented in factory records and optical tests, set new standards for sharpness and tactile precision. The Minolta Maxim 7000's 1985 debut marked autofocus as a turning point, triggering immediate design shifts and industry-wide strategy meetings. However, not all sales data, such as precise market share for multi-coated lenses, has been independently verified, and some patent dispute details remain sealed. Today, the compact, manual-focused lenses of the 1980s are still prized for their build and optical quality, a legacy rooted in documented technical breakthroughs. The evidence shows the era's golden age status rests on measurable innovation, not nostalgia.